Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on February 26, 2026, just 2 days ago. It introduces a method that acts as an active firewall for multi-agent systems, effectively intercepting and fixing errors to achieve an average accuracy gain of 6.3 percentage points on math benchmarks. The paper is titled AgentDropoutV2, Optimizing Information Flow in Multi-Agent Systems via Test Time Rectify or Reject Pruning. And as we'll see later, the way it dynamically adapts to task difficulty is really impressive. For those interested in the implementation, the authors have shared their code on GitHub. Figure 1 compares the previous approach with the new framework. The top panel shows the original agent dropout, which simply cuts out unreliable agents based on static rules. In contrast, the bottom panel illustrates AgentDropoutV2. Instead of immediate removal, it intercepts the output and enters a rectification loop to correct errors iteratively. The agent is eliminated only if these attempts fail, which preserves more valid information than the rigid predecessor. So, Figure 2 details exactly how this process unfolds. The top section maps out the test time pipeline, where a dedicated rectifier intercepts the agent's output. This module queries an indicator pool to find known error patterns relevant to the current task. If the output triggers a warning, the rectifier sends specific feedback, prompting the agent to regenerate its response. The bottom section explains where that pool comes from. It shows how the team mines failed trajectories offline, using a teacher model to distill error definitions into a structured database that guides the system during live testing. Well, having seen the pipeline, Table 1 now quantifies the impact across 9 mathematical benchmarks, ranging from GSM 8K to the difficult AIM competitions. The first 2 rows establish the baselines using a single agent and the AutoGen framework, which hover around 47 to 49% average accuracy. The real leap appears in the bottom row. By enabling the full retrieved indicators mechanism, the system achieves an average accuracy of 55.25%, a substantial gain over standard methods. Alright, moving beyond math, Table 3 extends the evaluation to the code domain. This table lists performance on benchmarks like MBPP and Live Code Bench. The first 2 rows show that the standard AutoGen framework averages about 46% accuracy. However, when the method applies generic indicators, shown in the bottom row, the average climbs to over 48%. Notably, on the harder Live Code Bench task, accuracy improves from around 29% to nearly 33%, showing that the pruning logic generalizes well to programming challenges. So, Figure 3 breaks down exactly how much effort the system spends on different tasks. These pie charts track the rectification process, where the light blue slices represent passing on the first try, and the pink slices indicate rejection. On simpler benchmarks like GSM 8K in the top left, we see a massive light blue section, meaning over 60% of outputs pass immediately. Conversely, for the difficult AIME 25 task in the bottom right, the pink area dominates, showing that nearly 70% of outputs are pruned to prevent error propagation. Now, Table 4 validates the system's design choices through an ablation study. The top row sets the high bar with the full model achieving 55.25% average accuracy. In the first section, we see that removing rectification entirely, shown as 0 iterations, drops performance to roughly 50.6%, confirming the value of the active correction loop. Finally, the third section reveals that substituting relevant indicators with random ones causes a similar decline, which proves that the semantic retrieval mechanism is critical for providing useful guidance. Wrapping up, 2 takeaways stand out. AgentDropoutV2 successfully shifts error management from rigid filtering to dynamic test time rectification. By using an active firewall to intercept and fix mistakes, it secures a 6.3% accuracy gain on math tasks without the high cost of retraining. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.